residing on a 1,400-acre, 1 million square foot mega site in the heart of Mississippi's Golden Triangle, a crossroads for an abundant transportation network. The 3.4 million ton steel mill is strategically located to serve a wide variety of steel-consuming industries that call the South home. With initial construction beginning in 2005, this state-of-the-art facility merges compact strip production, or CSP technology, with an integrated finishing mill, resulting in a cost-effective, higher quality product in a wider range of grades and sizes. With the completion of a $550 million expansion in the fall of 2011, Severstal Columbus doubled its capacity, expanded its capabilities, and further positioned Severstal Columbus as the benchmark for electric furnace steelmaking. Severstal's innovative steelmaking process begins in the scrapyard. Severstal uses a rich metallic mix, including high-grade scrap, pig iron, and hot briquetted iron, or HBI. Each specific customer's order dictates the precise scrap mix. The journey from scrap to steel starts when the specified scrap mix is transported to the facility's melt shop, filling a massive 180-ton clamshell bucket. An overhead crane descends from above, lifts the bucket of scrap, and hauls it to one of the facility's 2 electric arc furnaces, or EAFs. The EAF comes alive with a rumble that seems to shake the facility's very foundation as the clamshell doors on the bucket open, releasing the scrap into the furnace. The dual EAFs are the heart of the operation, their presence heard and felt throughout the entire plant. As the furnace lid swings closed, a single electrode is lowered into the scrap, causing a spectacle of cascading sparks, the visual counterpart for the thunderous din of the furnace. The electric arcs heat the contents to approximately 3,000 degrees Fahrenheit, melting the scrap into a heat of molten metal in under 40 minutes. The furnace is then tapped, its glowing contents poured into a 165-ton capacity ladle and transferred to one of 2 ladle metallurgy furnaces, or LMFs. Here, alloying elements are added to achieve the correct chemical composition for the grade of steel specified by each order. From the LMF, the ladle of molten metal is moved to one of the facility's 2 thin slab casters. A bottom spout allows the ladle to pour the molten metal into a tundish, or reservoir, and ultimately into a casting mold. Descending nearly 7 stories, the molten metal traverses down the mold's water-cooled walls, which harden the metal into a semi-solid slab of steel. At the bottom of the caster mold, the slab is sheared to a length corresponding to the customer's order and moved slowly into the attached tunnel furnace. The facility houses 2 tunnel furnaces, each nearly the length of 3 football fields, working independently to heat each slab to a consistent hot rolling temperature of around 1,900 degrees Fahrenheit. Leaving the furnace, the slab enters the 6-stand hot mill, where the 2.5-inch slab is reduced as specified by order to thicknesses from 0.054, or about the thickness of a dime, to about 1/2 inch. Once reduced to the specified gauge, the strip continues over a runout table, where the steel is cooled by water spray and coiled as a hot band, weighing as much as 44 tons. These hot-rolled bands may be used to manufacture a wide variety of products, including welded pipe and tubing, farm implements, or auto body frames. Or they may be further processed downstream into cold-rolled or coated steel products. The first downstream finishing process is pickling. The hot band is uncoiled and passed through a series of hydrochloric acid and water rinse tanks to remove iron oxide from the surface. Upon request, oil can be applied to the surface to help inhibit rust formation. Pickled and oiled products are typically used in heavy stampings. Severstal's continuous pickle line is unique among low-cost steel producers. The plant's pickle line is directly coupled to a 5-stand tandem cold reduction mill. This remarkable configuration is one of only 4 cold mills coupled to a pickle line in North America. After pickling, the coils may be further reduced in a cold rolling process. Each cold mill rolling stand successively reduces the thickness to a final gauge ranging from 0.014 to as heavy as 0.074 inches, or the approximate thickness of a nickel, again depending on the customer's order. The mill features a closed-loop gauge and shape control system, and a 360-degree rotating inspection table to ensure the highest quality surface and shape. At this stage, the coil is a full hard cold roll product primarily sold for roof decking. For heavier gauge applications, including some automotive and pipe and tube, the coiled hot band may be routed from the hot mill directly to our separate push-pull pickle line, capable of pickling product from 0.054 to ½ inch in widths of 36 to 74 inches. Batch annealing restores ductility to the steel for improved stamping and forming. Coils are stacked and annealed by heating in hydrogen atmosphere furnaces. After about 3 days in the furnaces, the coil moves to the temper mill, where the customer's specifications for surface finish and mechanical properties are met. This fully processed cold roll is used in lawn and garden products, appliances, tubing, and shelving. For corrosion resistance, hot-rolled or cold-roll coils may have a coating of zinc applied at a continuous galvanizing line. The coils pass through a cleaning section, vertical annealing furnaces, and a molten zinc pot. Vertical ovens bake the zinc to the coil. Inline tempering and tension leveling ensure the best surface and shape. Rust inhibitors can be added at this stage if the product will not be painted. Multiple hot-dipped galvanizing lines allow for improved scheduling and redundant capability, while further expanding product ranges from as light as 0.015 inches to as heavy as 0.130 in widths of 36 to 72 inches, with a wide range of coating weights. Automotive applications often require a galvanneal instead of galvanized coating. This process results in coatings which can be better formed, stamped, or bent, and which have a dull matte finish that allows for improved paintability. Typical applications for galvanized and galvannealed coils are any corrosion-resistant applications, including building panels, HVAC, household appliances, grain bins, automotive bodies, and other outdoor applications. Severstal Columbus is located at the convergence of transportation hubs. Finished products can be efficiently shipped by truck, rail, or barge to customer plants throughout North America. Through an unwavering commitment to product innovation, excellence, and unparalleled customer service, Severstal provides customers throughout North America with the most innovative, efficient, and high-performance steel solutions. From our high-tech Columbus facility, strategically located near a variety of steel-consuming industries, we continue to amplify our capabilities, accelerate distribution, and advance the future of steel.